Today's lesson is going to be on average rate of change. And so the average rate of change is a continuation of what we've done before with slope in grade 9. But we're going to apply it as a precursor, as a initial introduction to calculus, basically. But rate of change is how is one variable changing with respect to another. Very similar to what we've something done in the past. In fact, it's exactly like something we've done in the past, which is slope, which is y2 minus y1 over x2 minus x1. So to find the slope, it's finding the average rate of change. However, its context and the way it's used is going to be a little bit different. So what we're going to do is take an example question. There's a distance and time graph. This is my trip on a regular school day. Distance 0 will be me at home. When I leave home, first thing I do is I go and I pick up my nephews. That takes me probably 10 minutes. So at the 10-minute mark, I go pick up my nephews who live at probably about 1 kilometer away. From there, it'll take in the next 5 minutes or so, I will travel a little bit further, about 5 kilometers away to Tim's. Okay, so this is my nephews. Then I go to Tim Hortons to pick up, ice cap or something. And then what I'll do is I will come to work. So this is an additional 5 minutes. This is 15 minutes. And at that point, I am at school. This is the average day for me, average trip for me in the morning when I'm going from home to school. What we want to look at. Oh, so let me add one more thing in here, which is then at the end of the day, right, from school back to home, takes me about another 10 minutes and I'm back home. So let's ignore everything all the time that's being spent outside of the car. The average rate of change is simply the slope. So from my home to my nephews, my slope, or the average rate of change, is going to be the distance that I cover divided by how long I'm driving for. So I cover 1 kilometer in 10 minutes. So my average rate of change from when I leave the house to when I get to my nephews is 1 kilometer for every 10 minutes. If you want to shrink that down, like divide it, it would be 0.1 kilometers per minute, right? Because you want the rate of change to be in terms of the denominator variable. Let's go a little bit further. Let's say from my nephews to Tim Hortons, right? So the average rate of change would now be from 1 kilometer to 5 kilometers. That's going to be 5 minus 1. And then from 15 minutes to 10 minutes, right? At the 10-minute mark, I was at my nephew's. At the 15-minute mark, I'm at Tim Hortons. So that's 15 minus 10 turns into 4 over 5. That means my average rate of change from my nephews to my Tim Hortons is going to be 0.8 kilometers per minute. This is 0.1, this is 0.8. I mean, you can easily explain that by saying, perhaps here I'm in residential road, so I have to drive slower, and here I'm on the highway or I'm on a major street, so I can drive a little bit faster. And if we continue on that way, we can see that there is a general rate for each block. What happens from my school back home? So the average rate of change from school back home is going to be, well, I end up at 0 kilometers minus where I started, which I forgot to fill out here, is 10 kilometers, divided by the time that it takes. So I end at 30, I started at the 20-minute mark, so it's 30 minus 20, and this would be negative 10 over 10, which is negative 1 kilometers per minute. What does that negative mean? It means that I have established 0, the starting point, as home. So any number where it's positive, I am going away from home, and negative is coming back toward. So it just means direction. The speed, or the rate of change, is still the same. It's still kilometers per minute. The negative or the positive just gives me the direction. So the rate of change is very straightforward. It's just the slope. But then I want to add in something called a secant. So a secant is a line segment that connects any 2 points on your graph. Okay, so now to find the average rate of change from, let's say, from the time I get to my nephew's until I get home, what is my average rate of change? What's my average speed throughout the whole day? Well, to find that, I'd have to find the slope of this secant. This secant that's been drawn from my nephew's till home is what I would have to use. So the average rate of change would be where I ended off, which is 0, from where I started, which is 1 kilometer away, divided by the 30-minute mark and the 10-minute mark. So 30 minus 10, this would be -1 over 20. So it would be negative 0.05 kilometers per minute. Notice how this is a very, very small number, and it makes sense, because the rate of change is average. It's over this, and you completely ignore this speed and this speed, or you understand it's an average of these two speeds. This is a positive number, this is a negative number, so my answer would have to end up being some kind of a very small number that's almost an average of them. Imagine if I had done from the beginning of my day to the end of my day. That would have been 0 distance minus 0 distance over the 30 minutes that I'm out for. So my average rate of change would be 0, because where I ended up is exactly where I started. So if you're looking at it in terms of speed, the distance is 0, so it doesn't matter how many minutes I've been driving for. The average rate of change would still be 0.